Welcome to Study Loop.
So in this problem, we are given with the reaction equation of the formation of sulfur trioxide from the reaction of sulfur dioxide and oxygen. We are given the value of Kp for this reaction, and we are given the equilibrium partial pressure for sulfur dioxide and oxygen, and we are asked to find out the equilibrium partial pressure for sulfur trioxide. So as we know that there is a very simple relation between the equilibrium partial pressure and the Kp value, which is the equilibrium constant in terms of pressure. And for this reaction, the relationship will be equal to, as we know that the Kp is basically the product partial pressures over the reactant partial pressures, and the reaction coefficients increase to the power of that specific reactant or product. So for this one, it will be the partial pressure of sulfur trioxide, and the power will be raised to 2 because 2 is the coefficient of sulfur trioxide here, and it will be put over the reactant partial pressure. So it will be for sulfur trioxide, and also sulfur trioxide has a coefficient of 2. That means we will raise the power up to 2 times the partial pressure of oxygen. So here we know the value of Kp, we know the value of partial pressure of sulfur dioxide, and we know the value of partial pressure of oxygen. And from here we can easily find out the value of the partial pressure of sulfur trioxide. So if we just rewrite this reaction for finding out the partial pressure of sulfur trioxide, we can write it as square root of the Kp value times partial pressure of sulfur dioxide squared times partial pressure of oxygen. Now, if we just plug in the values, so the value of Kp is given as 0.345, partial pressure of sulfur dioxide is given as 0.135, and for oxygen it is 0.455. So it will be 0.135 square times 0.455, and from here we'll get a value of 0.053. So this is the partial pressure of sulfur trioxide in these reaction conditions.